Great, thank you. Hi, everybody. I'm Haley Sayers. Welcome to my talk. I run product management here at EXPANSE. EXPANSE, which I will get into in more depth later in this presentation, we are a cybersecurity company, and we help organizations understand their internet-facing assets where they have misconfigurations, things exposed on the internet, accessible by attackers that shouldn't be. We help them find these misconfigurations so that they can remediate them and reduce any risk. We work with large commercial organizations and government agencies. So for example, we could help a bank find that they have a database server hosted in the cloud that might be exposing consumer information or consumer data, so that they can go and fix that before it gets exploited. So today I'm going to talk to you about how the internet developed in a way that made it easy for attackers to exploit. I'm also going to talk about why attack surfaces are hard for organizations to manage, why it's a problem, and then how these two factors led us to build our products here at EXPANSE. And I'll end this talk with time for anybody to ask any questions that they might have as well. All right, so first let's talk about why the internet was initially created. And through this story, you'll understand why it was not actually developed with security as a first-class principle. So first, computers in the 1960s, when they were first developed, they were really large. They took up entire rooms. They took up a lot of physical space. And they were also very expensive. They cost tens of thousands of dollars or hundreds of thousands of dollars. This meant that there weren't that many powerful computers to go around for military personnel and scientists who needed them. So to solve this problem, the Department of Defense, ARPA, Advanced Research Project Agency, they're the predecessor of DARPA, who actually initially is where EXPANSE spun our product out of. Our founders were part of DARPA. So they actually created the precursor to the internet in the early 1960s. They decided to try to connect a handful of large computers so that they could share software, share research information, and even share storage space across the entire country, across multiple states. And spreading powerful computers out like this geographically was actually advantageous when it comes to protecting our nation. Geographically removed or distributed computers meant it was harder for an enemy to take out all of our kind of intellectual property or intellectual capital with one blow. So ARPA set out to create a network that connected the country's major computing resources, and this is going to be called ARPANET. It had 4 main hubs: the University of California, University of UCLA, UC Santa Barbara, University of Utah, and SRI International. And once connected, a researcher could sit down at a computer at one hub and pull anything off of a computer at another hub. They were connected. One of the initial problems that they had to solve was connecting several different types of computers that did not speak the same language. So this was a primary problem, getting these computers to speak the same language. They needed to figure out 2 things in order to make this happen. They needed to figure out how they're going to package up data, communications to and from different computers, and how they were going to route it to the right place. So their solution was to create a device called an IMP, or an Internet Message Processor, basically a router. It functioned as translators, and each end device was connected to an IMP, which would package up a computer's commands into a packet of data. It would figure out how to send it to go, and this meant that any device type could be connected, and it didn't need to be bogged down with like that routing calculations or translation, since the IMPs took care of this. And this is really the predecessor to the internet. So to recap, the early internet was designed to connect computers. A new device was created, an IMP, which is basically a router, which could take data from one computer, break it up, package it, route it to a new computer to then unpack it and reassemble it. And this system was what the internet was based off of. In the 1980s, a set of communication rules called TCP/IP was created. And this is based off of the IMP design. And what TCP/IP allowed is, so you had a bunch of different computers in various networks that could communicate with each other, but you couldn't communicate across networks because there's no standard language for that. So TCP/IP is a set of rules for communication so that we could connect all computers and that there's one sort of universal language. So then over the next several months and years, more and more institutions, government and educational institutions hooked up their computers to the network. And that's where we really saw the internet begin to expand in terms of scope and various use cases. So as the internet grew, people started designing different protocols or rules for exchanging information. So every time there's a new use case for the internet, there's a new protocol that was developed to support that use case. So an example, one of the first examples of a protocol, one of the first protocols that was created, is called Telnet. And Telnet is a way to interact with a machine via a terminal. Maybe you guys have used this before in order to access maybe your college's like resources or something like that. If you're in computer science classes, you probably use something like Telnet in order to do that. So one way that you interact with your computer now is via a graphical user interface, a GUI, which is like a desktop and a mouse. But back when Telnet was created, we didn't really have good user interfaces. And one way that a lot of people interacted with computers in the early days of the internet was actually through terminal. And so then being able to, so then we created a protocol to allow you to access another computer via its terminal. This is called Telnet, so that you could use another computer's resources in case your own computer wasn't equipped with something that you needed. Another example of a protocol that was created in the early days of the internet was a file transfer protocol, or FTP. And this was a way to share files. So you can begin to see, as there's use cases, you know, a researcher needs to use someone else's computing resources. We create a Telnet. Someone needs to send files. We create a FTP. You can imagine that's how HTTP was eventually created, email services, stuff like that. Every time there's a new use case for the internet, we created a protocol. And to kind of give you a hypothetical example of how this all fits together, imagine you have a researcher. So a lot of the early use cases of the internet were researchers and scientists, especially in educational institutions. So imagine there's someone working at MIT, they need to run some calculations on their computer, but their computer is not equipped to handle it. But they have a researcher over at Stanford who has a better computing. I went to Stanford, so I'm, you know, making a joke here. Stanford had better computing resources. You can imagine that that researcher at MIT, they're going to telnet into the Stanford computer, which grants them access. They're going to then share a file, FTP. We're going to file share the file over to Stanford's computer, telnet in to run the calculations, and then send the file back to them using FTP. So that's an example of how you can use another computer using these two different protocols and how that interaction might work. So you can see with that example that I gave you, FTP and Telnet, that these early protocols are really designed for open access so that entities could communicate and share resources. They were really not designed with security in mind. That was not kind of initial, that's not why the internet was initially developed. So a lot of these early protocols were not designed with security in mind and rather kind of led to kind of computers being open, easily accessible so that we could share resources, et cetera. And a lot of organizations today in this modern era still expose a lot of these services on their network, which make them vulnerable to attack. Next, I want to talk about why the internet is small. This is all going to make sense when I get into EXPANSE's products. So at first, this concept should sound contentious because we think of the internet as a very large space and place. A lot of different devices are connected to the internet. It seems massive, it's globally distributed, but it's actually very easy to exploit for attackers now, and that's what I mean by small, which I'll get into. First, let's get back to the concept of devices communicating on the internet. How do devices reference each other and know where to send their communications? Well, they use IP addresses. Every single device on the public internet has an IP address. This is how communications are sent between devices. The IPs are the identifiable information or the name of an address. So if you think about the mail system, if you're sending mail to a house or a business, you use the address to reference it, and that's how we know where to route the mail. Similarly, with computers on the internet, we use IP addresses. It's really the same concept. So every device that is accessible on the public internet has a public IP address, and there's 4.2 billion IP addresses in the IPv4 address space. So if a bad actor wanted to go and understand every single device that was connected to the public internet, they would have to scan all 4.2 billion of these IP addresses. So imagine a scenario where an attacker realizes that Telnet, which is the protocol that lets you remotely access a computer, they realize that they can actually use that to their advantage to infiltrate an organization's network or get sensitive information. If they want to find all instances of Telnet on the internet, they could do that if they're able to scan 4.2 billion IP addresses. But that used to be really hard to do. And so organizations were generally protected from kind of being exposed just by having a public IP address. In fact, sorry, I have a bad cough, so I'm going to be coughing a bit throughout this presentation. In fact, if you go back 15 years, scanning the internet was hard to do. You could get a PhD at a university for scanning the internet just one time because it was that hard and that difficult. There were not kind of tools or open source technology in place to help you do that. It would take months for a team of researchers to go through the internet and determine its structure, understand what it looks like and what devices are live. As recent as 2012, you actually needed illegal capabilities in order to communicate with every device out there in a reasonable amount of time. And this paper that I have here on the screen, which you should look into, is pretty interesting. They actually had to publish it under a pseudonym because what they were doing was illegal. They took over a botnet called Karnabot to index the internet using embedded devices. So they took over embedded devices and used that to figure out the structure of the internet and all the devices out there using a program called Nmap, which if you guys ever enter the security industry, you'll learn Nmap is an open source tool for scanning the internet. Up until only a few years ago, you needed illegal methods to determine the structure of the internet, and it took scientists, researchers, academics in order to be able to do it. Everything changed in 2013 when there's an algorithm called ZMAP that came out of the University of Michigan. So ZMAP increased the speed that you can scan the global internet, 4.3 billion IP addresses, by 1,500 times. So you can appreciate how much that improved our ability to scan the internet in a rapid amount of time. So it used to take weeks or months to scan the global internet, but now you could communicate with every single public IP address in the IPv4 address space in less than 45 minutes. So think about the impact of that. If I'm an organization and I misconfigure an asset and I expose something like Telnet that allows an attacker to remotely access my computer, someone could find that within 45 minutes just by regularly scanning the entire internet. So that's pretty scary for organizations and motivates them to need to lock down their perimeter. But let's talk a little bit about ZMAP and what the improvements there. So historically, if you're trying to scan the global internet, you have to keep track of what you've already scanned and what's left to scan. So if you have numbers 1 through 10, a reasonable way to do that is to scan 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But people own IP addresses in a block, like an organization. So Dell Technologies owns kind of a block of IPs in a row. And if you scan them all in a row, that might look like what's called a DDoS attack, a denial of service attack, because you're quickly sending packets to a bunch of different IP addresses in a contiguous range. So that will look like a denial of service attack to them. They'll probably block your scans if you try to do that. You've probably heard in the news of DDoS attacks that have taken down websites and stuff like that. And now there's protection against it. So they'll just block the scans if it looks like a DDoS attack. So the first thing that ZMAP did was it actually borrowed an algorithm to randomize the IPs the order of the IPs that it scanned. So basically bounces around the circle of IPs. So it guarantees that you only scan an IP once, but it goes about it in a random order and it doesn't have to keep track of what IPs it's already scanned, which would take a lot of computing power for 4.3 billion IP addresses. So this randomized the order of IPs so that you could scan a lot faster. Because if you're scanning in a contiguous, 1, 2, 3, 4, 5, you have to wait a given period of time so that you don't make it look like you're DDoSing someone's network. Another thing that's convenient about this that I noted is that you don't need to keep track of what you scanned and what you haven't. The algorithm takes care of that. So this simplifies the processing logic of figuring out what you need to scan on the internet. The second advancement of ZMAP that made scanning the internet super fast is that when you scan the internet, you go through what's called a handshake. So you send a message to an IP, it sends a message back to you, and that's how you understand what's on that IP address. And that information getting shared back and forth, that usually is quick, is pretty quick. It takes a couple of milliseconds, but if there's a lag, even delayed just a second or two, that slows down scanning overall, and that can add up across 4.2 billion IP addresses. So what ZMAP did is it packaged that handshake into one packet and then it let the packets come back at its own leisure. So now it got rid of that kind of rate limiting aspect. So you could scan a lot faster, you could just shoot packets out, which led to a lot more rapid scanning. So given these advancements, other parts of ZMAP, again, if you want to nerd out, you can read this paper that I've linked here. You can now scan the internet really fast. So organizations can't just abandon misconfigured assets on the internet and think that no one's going to find them. They're not kind of hidden in the noise of the internet anymore, because it's now trivial with ZMAP in 2013 for someone to go and scan the entire internet, a bad actor, and index every single device or insecure device that's out there. So at this time is actually when our EXPANSE co-founders took a big bet. They saw this paper get published. They're like, wow, that's going to change perimeter security for organizations. They're going to have to think like attackers do and know that they're going to have to, be aware of anything that's exposed on the public internet and be ready to detect that and resolve it within minutes. Otherwise, someone else might find it on the internet because it's now easily accessible or easily exposed. This has fundamentally changed how we think about the internet and gathering information on it. And this is why I am saying at the beginning of the section that the internet is now small to attackers. We've actually seen this in recent years with something that we have called honeypots. Honeypots, we maintain these within our organization. They're basically traps that are intended to mimic cyber attacks. They're passive listeners that we've set up to listen to internet traffic and to analyze kind of what's trying to scam us. And what we saw actually, if you guys heard about WannaCry in 2017, this was a ransomware attack that exploited a protocol called SMB. SMB allows you, similar to Telnet, to remotely access a computer. And so basically, we have these honeypots that saw kind of incoming inbound scanning traffic. And we saw once the ransomware worm was disclosed, once people announced WannaCry, we saw within minutes our honeypots were detecting scanning traffic for SMB. So just within minutes of that being disclosed, like, hey, this thing is SMB is highly vulnerable to WannaCry, we saw bad actors scanning our honeypots looking for exposed SMB. And so that just goes to show that you're no longer safe. Within minutes, you have to respond to these sorts of things being publicly exposed. Okay, so we just talked about why the internet is now small from the attacker's perspective and how this has come about in the past few years since ZMAP was released in 2013. The second point that I want to make is why network perimeters have never been more complicated. So the first part that I just talked about is kind of the technology advancements in scanning that motivated EXPANSE's product. Now I want to talk about the pain points for organizations, why this is especially painful for them, and how we kind of found product market fit with our product, which I'll go into more detail in a bit. So first, what EXPANSE does is we look across the entire global internet, across 4.3 billion IP addresses, and we look for any asset that looks like an organization's. So maybe we sign Accenture, they're actually a public customer of ours, so I can mention them. Maybe we sign Accenture as a customer. We want to find all assets on the global internet that look like Accenture's, and we're going to tell them where they're misconfigured, where they're maybe exposing something like Telnet that allows them to be remotely accessed. Show them that asset so they can go and remediate it and fix it and make sure it's secure so that attackers can't exploit it. So at the beginning of the engagement, we go and do that mapping process of looking for all of their assets. And in 100% of our engagements to date with customers, we always find assets that they did not know about, unknown assets. And in a security organization, if you're not tracking an asset, you can't protect it. And it's outside your visibility. So your security teams, none of your technology or tools know about that asset, so you're probably not securing it. On average, we find 30% more assets on the internet for a customer than what they were already tracking internally. And I'm going to talk about some of the kind of changes in the business environment that have led to these unknown assets. So the first is just kind of growing international expansion. First, I'll talk about IP address space. So if you're an organization and you want to work on the internet, you have to go and get IP addresses registered to your organization, or you have to host stuff in the cloud. So you either host your own infrastructure, it's on premises, it's on your own IP space, or you host in the cloud. we've seen, and there's some central managing unit that manages all the IP addresses across the internet, and they register them to an organization. So if Haley Incorporated wants to spin up a website and I want to host it myself, I'll go to this regional internet registry, which manages all the IP space. I'll ask for a block of IPs. They'll register them to my organization, and then I can host my assets using those IPs. So we look at IP space for our customers, and we see that this grows over time. So that regional internet registry where I go and get my IPs registered, there's actually one for North America, South America, Europe, Asia, etc. And we saw in this graph for a large tech company, the x-axis is time and the y-axis is the number of IP addresses that are registered to the organization. We see that this is growing over time as they're expanding internationally and they're registering IP space in Asia and Europe and continuing in North America. So just as businesses grow in general and expand into new geographical regions, their attack surface is expanding, and this can, increase the size of their attack surface. Another reason that we see why network perimeters are more complex than ever are mergers and acquisition events. We work with large organizations who are frequently acquiring new companies. These are pharmaceutical companies, financial services companies, technology companies. You're not supposed to read this graph here. It's meant to show how complex it can be. You might be acquiring a company who acquires a company who acquires a company. And what happens during an M&A event is your security team has to independently assess that acquisition. So say I'm Haley Incorporated and I'm acquiring Acme. My security organization will try to understand all of Acme's assets so that I can integrate them into my own security center and make sure that I'm able to monitor them and that I know about them. So I do my independent assessment. And I also ask Acme, I say, hey, can you send me your asset list so I can integrate your assets? When you're acquiring a company that's acquiring a company that's acquiring a company, they're not going to know all of their assets. And you might be subsuming risk as a result of that. You might be subsuming unknown assets because someone's not giving you their full asset list or you're not able to independently discover them themselves. So this can add a lot of complexity and increase the unknown unknowns for organizations. And we target one of our primary customers, customer profiles or customers that organizations that do a ton of M&A events, because that adds just a ton of complexity. We also see some really bizarre edge cases of things that are exposed on the internet just because more things in general are connected to the internet. An example are building automation and control systems. So a scenario here for how a building automation control system might be exposed is that a new building is being built for a tenant. Say Haley Inc. Got a new office building in downtown San Francisco. The construction company needs internet connection and in order to be able to plug in their building automation control system. That's, maybe that's powering the lights and powering the AC, if we're lucky enough to have AC in San Francisco, all those sorts of things. So that construction company will go out to an internet service provider, they'll get IP space and they'll hook up that building automation control system. And then when Haley Inc. moves in, the ownership of that building automation control system really should be moved back to my IT org, but often that doesn't happen. And so we see that these systems are connected to the internet. They're not even registered to the organization who's impacted by it. And the banner, so when you scan these devices, it'll return the response when you scan it, often actually includes the address. It'll say 455 California Avenue in San Francisco, Haley Inc. And so it's really easy for attackers to scan the internet, see this response and be like, wow, this is the building for Haley Inc. I wonder what trouble I could cause if I cut the power or turn out all the lights, whatever else you're able to kind of control the building and automation control system. We've actually seen some really scary instances of this where even hospitals had their building and automation control systems online. And you could imagine if a bad actor got access to that and shut off power at a hospital, that could cause serious issues, not just business disruption, but physical risk to human beings. So that's super scary. We see weird, bizarre things connected to the internet, like building automation control systems that weren't really relevant 10 years ago, but are becoming increasingly relevant as more things are connected to the internet. Another example of why networks are more complex than ever is work from home. I'm sure you guys are all sitting at home right now on your laptops. And this can create a lot of complexity for organizations who are trying to manage infrastructure, corporate assets, stuff like that. So RDP, remote desktop protocol, that's a way similar to Telnet for you to remotely access another computer. We see when people work from home that a lot of them need to remotely access their workstation at work in order to access files, access software, et cetera. And they do this over RDP. But if that's exposed to the public internet, it makes your own computer at risk and sensitive information at risk for being exploited. So we actually worked with a consulting firm. This is pre-COVID. So consulting firm was a good example of people working all over the world, from Starbucks and hotel lobbies and at home, et cetera. And we saw RDP constantly exposed across the entire global internet as their consultants were going out in the field and their assets were misconfigured and exposing their computers as a result to attackers. This is incredibly bad, just a metaphor for what this is. It's like leaving your computer on the street for anyone to try to go and access. The other challenge of this is, in that example of consultants, they're plugging into hotel Wi-Fi or Starbucks Wi-Fi, and that is not an organization's own IP space, it's some consumer dynamic IP space, and so that's really hard to track. You have to really either be tracking that individual asset, have an agent on that endpoint, or you have to do what EXPANSE does, which is scan the entire global internet for anything that looks like your organization's, even if it's not your own IP space, even if it's AT&T or Comcast IP space. So work from home has added a lot of complexity for organizations to manage their attack surface. Okay, the last kind of business organizational development or trend that's added complexity is the migration to the cloud. As you probably know, a lot of organizations are moving from on-premise data centers, moving to the cloud so that they can not spend time hosting their own assets. They can make use of like Google and Microsoft and Amazon's kind of computing power and all the security aspects that those cloud service providers often offer as well. But this complicates things. Rather than having your own kind of IP address, like how I mentioned, you go and get a block of IPs registered to your organization, you actually hand over control to a cloud service provider to host your organization's assets in their IP space. And so this has added additional complexity because it's not on your own IP space, it's in the cloud. A lot of security organizations aren't used to working with cloud security. It's kind of generally a new space. There's like no unemployment in that area because there's just not enough people trained with cloud security. We're retraining a lot of kind of security operations centers to learn how to work and secure the cloud. And it's really just a growing space in a new reality. And we see that as a result of cloud being easily accessible, anyone can host something in the cloud. I could go and spin up a website right now using my EXPANSE email address, and I could host it in Amazon relatively easily. And because of other things like an organization being geographically located, or maybe you have a developer who's trying to move really fast and they're going outside IT protocol. As a result, you get sprawl across the cloud where your IT teams might not actually know about everything that's hosted in the cloud, which results in shadow IT or things kind of outside your visibility. And what we're able to find at EXPANSE is how extensive this sprawl is. We see that organizations on average actually have 15 other companies hosting their assets. So 15 other cloud providers hosting their organization's assets. When we go into a company, into a prospect or a sales deal, and we'll say, hey, like, what cloud providers do you use to host your assets? They'll say something like, oh, we use Azure primarily and AWS for this part of the business, really just those two. And we'll say, well, what if we could tell you that you actually have sprawl across 10 other hosting providers? Jaws will immediately drop. A lot of that is actually shadow IT or someone not following processes, and this leads to a lot of unknown unknowns and where things are misconfigured in the cloud, exposing sensitive data, granting unwanted access to an organization's network, et cetera. So all those reasons are many of the reasons why we see organizations have kind of assets exposed on the internet that they don't know about. This has added a lot of complexity and made this very fruitful for attackers to go and try to exploit. And I'll talk about how Expanse leveraged that to build a product to address that pain in a bit. But the last point that I want to make here is that adversaries are already leveraging this as an attack vector. The problem is already here. We are not, working on hypotheticals. We already see these as legitimate attack vectors. On the dark web, for example, I mentioned RDP, how that's equivalent to just leaving your laptop on the street. You actually see people selling RDP exposures on the internet, just $10 a pop to buy an RDP exposure for some major organization because it's so likely that this can be exploited for sensitive information. And so we already see attackers identifying all instances of this misconfiguration on the internet and actually selling it, compromised instances of RDP on the dark web. We also see recent highly publicized exploits in the news that happened on network perimeters. An interesting one you may not have heard about is this one here, Baltimore's 911 system. What happened was it was hacked in 2018 and suffered temporary disruption for 17 hours that forced city officials to resort to manual operations to handle all inbound calls. This is really bad because Baltimore is a huge city and now they don't have a computer handling like dispatching and incoming calls, and they had to manually do it. So everyone calling about an emergency had to have a human pick up the phone and deal with their inbound call, which caused huge disruption and again, like put human lives at risk. What's interesting about this is I doubt any attacker was thinking, hey, I'm gonna go hack Baltimore's 911 system. Instead, they're probably just, opportunistically scanning the whole internet to find where something's exposed and then just like pouncing on that rather than targeting Baltimore 911, like they're looking across the entire global internet. They took advantage of this one particular exposure, which is scary. You can't really rely on security by obscurity. You can't just hide in the noise of the internet. Equifax is another great example where I believe they were exposed on a foreign subsidiary in South America. So again, that M&A event can lead to complexity, things outside your visibility, and that's actually where Equifax got hacked, not on their own core corporate asset, but actually on an acquisition, which we know adds a lot of complexity for security and IT teams. So a lot of instances of exploits in the news. Other recent ones, all the databases that are exposed on the internet that contain PII, personally identifiable information, passwords, things like that, databases. Capital One's S3 bucket. Those are examples of misconfigurations on the public internet that Expanse is well suited to identify. All right, the last point I want to make is that existing security products are not well equipped to handle this problem. So one, we noticed a trend in the internet that it was not designed with security in mind. Two, we noticed technology advancements that attackers could use to their benefit, and Expanse wanted to get ahead of that and try to leverage that scanning technology to actually build a product. Three, we found product market fit with organizations where this was a real problem with them, given the complexity of their organizations and just kind of the modern era of how organizations develop. Four, we saw it is an active threat. Things are happening in the news. This is legitimate and real, and chief information security officers need to address it now. And then five, we realized that existing tools out there weren't well suited to solve this problem. And I'll talk about why. Okay, so traditional security tools, there's a set of products called vulnerability management scanners, and what they do is scan assets for more vulnerabilities, or something called a CVE, which gives kind of like a risk rating of how bad a particular vulnerability is. However, to use these tools, you have to point that scanner at a set of assets. So the scans are really only as good as the asset list that you point it at. And we already know if we're finding 30% more internet assets than what a company's tracking, then their vulnerability management scanners are missing that 30% of internet assets, so they don't have good coverage with it. Also, they don't work as well in the cloud. They're meant more for static IP space. To get coverage of cloud assets, to scan cloud assets, you have to deploy instances in the cloud using like a Qualys, which is a VM scanner, like using their agent, or you set up an integration with your known AWS or Google accounts and say, okay, you have access to this, scan everything in it. But both of those really rely on either everyone in your organization following that protocol and spinning things up with the agent installed, or they rely on you spinning up cloud assets within known accounts where that VM scanner has access. And again, we know people aren't perfect. They don't follow protocol. A lot of things will be done outside of either without agents or outside of known accounts. And so those tools don't actually have coverage of your entire cloud assets. So they're missing a lot as a result. Okay. So we've gone through a lot of bad news so far. The internet was built for open communication, was not built with security in mind. It's now small to attackers, 45 minutes to scan the entire global internet. Network perimeters are very complex for organizations. Many breaches do occur at the perimeter, and existing tools don't solve this problem. So how can EXPANSE help? What have we built? So what EXPANSE has done is leverage that scanning technology to scan the entire global internet, 4.3 billion IP addresses, index every single device that is accessible on the public internet. And then when we begin an engagement, we use machine learning and our own internal tools to understand, okay, which of these assets are relevant to an organization. So Haley Inc. wants to sign with Haley Inc. wants to sign purchase EXPANSE's products. EXPANSE will map all assets that look like Haley Inc. By looking across this entire global inventory of all internet connected assets. It's a huge data problem and opportunity for us. So not only will we show you all of your internet facing assets, but we'll show you where they're misconfigured, where you might be exposing something that puts you at risk, like a database server, like RDP, like Telnet, like FTP, that makes you vulnerable to attackers. We'll continue to look across the global internet for assets that look like you on a regular basis. So we know your organizations are spinning things up in the cloud on a regular basis. So we'll continually index, we'll look for things that are misconfigured, maybe you made a firewall update and it's misconfigured and exposed some sort of service. We'll be able to identify that pretty soon after that misconfiguration happened. And we'll give organizations all the information that they need in order to go and remediate and fix that so that their attack surface is secure. So that is the product that EXPANSE has built. So by taking this outside-in approach, we scan the entire global internet. We're able to find those unknown unknowns that organizations might not be tracking because of those trends that I talked about, like migration to the cloud, M&A, et cetera, work from home. So in this particular example, we're able to find 200% more assets than what a company already knew about and was tracking, which gave them crucial visibility. So that kind of global perspective, global look at everything across the global internet, identified more assets than what they were previously tracking. This is particularly relevant in cloud. So we did an audit for a large financial institution. They told us everything they thought they knew in AWS and Amazon, and we compared against what we were able to find, and we found 2x the number of assets. So again, that unknown unknown is really scary for large organizations because their VM scanners, all their security products don't have coverage of those unknown assets. And if something gets exposed, like a database server that hosts, holds customer private information, they won't know about it. And so if we're able to find 2x as much, that's scary. They might be out of compliance on those unknown assets. They might be offering attackers a way into their network. They might be exposing private sensitive information for which they could get fined or whatever. So it's a huge risk to have this lack of visibility, and we provided 2x the number of assets in cloud than what they were tracking. Another interesting thing about security that we learned or we know is that security organizations have a large scope of responsibility and visibility, and they have a ton of tools. When I first joined EXPANSE, I actually started on a customer-facing team, which I recommend for anyone who's new into product management. I actually managed the product for customers, and it really helped me learn about their pain points, how they're trying to use the product and be successful. Then I was able to move into product management after that. But what I learned is my main users had like 60 or 70 different products that they were using. That's insane. Imagine logging into 60 or 70 different products a day just to get your job done. That's just unfeasible. And so being able to build a security product that plays well with other products and integrates with other products and lets them do work and the tools that they're already using to do work, that's critical for adoption and operationalization. And I don't think any security product would be successful if it didn't think about how it integrated into the rest of the ecosystem. So in this example, we knew that a customer's vulnerability management scanner wasn't scanning their whole internet or their whole attack surface, because they were only plugging in a subset of assets. They're only sending in a subset of assets to go and scan. So what we actually built out is an integration for them where EXPANSE discovers all those internet-facing assets, and we automatically push them to the VM scanner to be scanned. So it's particularly helpful in cloud, which is where they had the worst visibility. And this made sure that their VM scanner had full visibility into their cloud assets and that they're scanning them for deeper scans for misconfigurations, non-compliance, et cetera. By integrating with the rest of their ecosystem and making sure that we push our data and our findings and insights into the tools where they do work, this also decreases time to value. It makes them action the product faster and get value out of the product faster. One way we measure operationalization or usage of our product is actually by how much they're able to reduce their attack surface, how much they're able to find misconfigurations or exposures in our product and go and remediate those issues. And so for this particular organization, within 1 month, they're able to make pretty substantial improvements to their attack surface. They reduce instances of RDP, that example of leaving your laptop out on the street, by 30%. Unencrypted logins, where someone could sniff your password if you're logging in. It's pretty bad to have that exposed. Critical certificates, so maybe you navigate to a website and see the certificate's expired, so your browser doesn't trust the website. They're able to reduce all of these by pretty substantially within just 1 month, because we're able to provide valuable data that plugged into their workflow and ecosystem, so they're able to action it easily. Another way that we measure success is how fast they can action on our data. And so in this particular use case, we understood where they want to do work. They wanted to, EXPANSE discovers a misconfiguration. We send an alert in their alerting system. They use Splunk. That opens a ticket in their ticketing system, which they use ServiceNow. And it needed to get routed to this particular POC point of contact. And so we're able to basically build out that workflow through integrations so that as soon as we discover something that's misconfigured, they're able to remediate it within 30 minutes, actually, for this example. And so when I was talking about scanning improvements, where you can now scan the internet in 45 minutes, if this organization can fix the issue within 30 minutes, that's pretty good. And that means that, by the time an attacker scans them, this thing might have already been fixed and they're no longer exposed on the public internet. Okay, so I talked a lot about how the internet developed, how scanning improvements, how it's become easier for attackers to scan the internet, and the internet's now small. I talked about why network perimeter security is hard and complicated and complex for large organizations. I talked about how that's led to a lot of breaches in the news on network perimeters, and how that's led EXPANSE to take a bet and build a product in this area to address this need. And I talked about kind of some of the ways that our product has been successful. I'd love to open it up for any questions. I also have provided my email address here, so you can email me with any follow-up. And we are hiring as well. And so if you're interested in checking out our career page, please go ahead and do that. We're hiring product managers across, as well as other roles across different functions as well. So I'm not sure exactly how this could work, but if there are any questions, please let me know and I can address it in the last kind of 10 minutes that we have for this presentation. All right. Well, please feel free to email me, find me on LinkedIn, and I would love to chat with any of you about your product management careers or EXPANSE as well. Thank you so much for your time.